Hello, everybody. Welcome to session 3, unit 7, module 2. Okay, today what we're going to be doing is a problem string, our 2 millionth problem string. It looks like we're going to have one every single day the rest of the week. All right, but we're going to do it on a clock. We're going to kind of picture a clock. You'll need your student book page 269 for that, please. Your workplaces, we're going to introduce a game called Quotients Race to 100. You're going to need your student book pages 270 and 271 for that. And then when we're all done, make sure you do the student book page 272 for homework. Let's go ahead and open your books to page 269 and take a look at the problem string that is there. All right. On your page, you have a bunch of clocks. And what we have to do is solve division problems using clocks. So our first problem to our problem string is how many half hours are there in 2 hours, right? So on your clock, go ahead and draw a line where a half hour would be, right? So I'm going to take my line here and I'm just going to divide it in half, right? Because from 12 to 6 is 30 minutes, and then from 6 to 12 is another 30 minutes. So I see that there are two 30-minute time periods in 1 hour. But if I have two of those hours, that gives me 2 times 2, which is 4. Our next problem asks, it's just the opposite. What is a half an hour divided into 2 equal parts? So now we're going to draw that same line down the middle of our clock, right? But then we're going to divide it into 2 parts, right? So I'm going to take another line here and I'm going to draw it across. There we go. So I've divided my half an hour by 2. What does that give me? Well, it kind of gives me 15 minutes. And what is 15 minutes when we think about an hour, right? It's 1/4 of an hour. So by dividing a half an hour in half, we get 1/4. So how many thirds of an hour are there in 4 hours? Now a third's going to be a little tricky because that's 20 minutes, right? Oh, look at that. That was awfully nice of them to do that for me. So I'm going to go right here to the middle, and I'm going to take another line, and I'm going to go this way. So how many thirds of an hour are there? Well, there's one, and I draw the line again. There's 2, so there's 3. There are 3 thirds of an hour in 1 hour. So how many of them are in 4? Well, I'm just going to multiply 4 times 3, right? 4, 3, 6, 9, 12. So there are 12 1/3 of an hour in 4 hours. Good. All right, let's go to the next group. Okay, so then what is 1/3 of an hour divided by 4? So again, we're going to draw our 1/3 of an hour. And now what you have to do is you have to ask, if I divide that by 4, how am I going to divide that by 4? Very simply. When you think, what is our 1/3 of an hour, what does that fall on? That falls on 4, right? So when I divide that into 4 spaces like that, that's 5 minutes, right? 5-minute increments. 5-minute increments is 1/12 of an hour. So 1/3 divided by 4 is 1/12 of an hour. Good. So how many quarters are there? Quarters of an hour are there in 3 hours? So here we have our 3 hours, and we need how many quarters of an hour, right? Quarters of an hour are pretty simple, right? We go from the 12 to the middle, and then we go from the middle to the 3. But we want to know how many of those are there in an hour. I know I'm not drawing straight lines here, but you get the gist of what I'm doing. I should have just drawn straight across. So how many quarters of an hour are there in an hour? Just like a dollar, 4 quarters. In an hour, there are 4 quarters too. We have 3 hours, so 4 in the first hour, 4 in the second hour, 4 in the third hour, which means that we have 12 quarter of an hours in 3 hours. What is what is a quarter of an hour divided into 3 equal parts? So if we go ahead and do what we did with the above clock and just show where a quarter of an hour would be, where does this line end up? That line ends up at the 3, right? So very easy to break this into 3 parts then, right? I just got to go up here for 1. And then I have to go right over here for 2. Right? And there are, again, just like our 1/3 of 4, or 1/4 of 3 is 5 minutes again. And remember, 5 minutes is 1/12 of an hour. All right, so I hope that worked out well for you and you got those answers. Make sure that you pause the video in reverse just to make sure that you have the answers that you're supposed to have. Now we're going to move on to our game called Quotient Race to 100. You'll need your student books, pages 270, 271. So what I want you to do is players are dealt 5 number cards in each round and use them to create division problems in which 2 cards are the divisor and 3 cards are the dividend. Players try to arrange their cards to produce the greatest possible quotient. They solve their problems, check their works from their partners, and then you keep going until the total quotients equal 100. So I'm sure you're asking, where am I going to get these number cards? You don't necessarily need, you can just play with a deck of cards, right? Take out your kings, queens, jacks. You could keep your aces because that's 1, but you keep your cards 1 to 9 and you just mix those cards up. You can pull number cards out that way. All right, so I'm going to go ahead and take a look at that from our Bridges website. Very similar, right, to what we just discussed. And here are here's our record sheet, which will be found as a link on your assignment page. All right, so what I'm supposed to do, right? Let's go back here. I'm supposed to pick 5 cards so that 2 cards go for my divisor and 3 go to my dividend. So if I'm going to go to the game, I got to pick 5 cards. 2, 3, 4, 5. I have the 1. I have the 5. We're not going to do the 10. And we'll do the 8. Again, we have a 10. There we go. We have these 5 cards. Now I want to produce the largest quotient that I can. So I'm going to pick the 12 and I'm going to divide that into, oh, look at that. I picked 1 too many cards. 885. All right. So now I'm going to need my pencil. And we'll do that work, right? So 12 goes into 885. 12 goes into 88 7 times. So I'm going to pick 7. That 7 times 12 is 84. I'm using the standard algorithm here. 8 minus 4 is 4. And I bring down my 5. However you choose to do your division problem and however you're most comfortable doing long division is totally up to you. I'm going to multiply 12 into 45. It's not quite 4, so it's 3, right? Because 4 times 12 is 48, and I only have 45. So we'll go 36, subtract, and 9. So my answer is 73 and 9. My remainder, oh, it's not letting me put the remainder over there. 9/12. Or if I reduce 9/12, I have 3/4, right? Ah, lucky me. Look at that. I almost got my 100 points already, right? So I'm going to write my problem down. I had 12. No, I had 885. Divided by 12. And I had 73 and 3/4. Or remainder 9. Okay, so we're going to keep playing back and forth until one person gets to 100. The first person to get to 100 wins. All right. So again, just go ahead and use a deck of cards. Remove the ace, not the ace, the king, queen, and jack. Mix your cards up and then make your problems with the deck of cards. Or go ahead and roll dice. You could do the same thing with dice. Just roll your dice 5 times and then use those 5 numbers. Anyway, you guys choose to play the game is going to work, and it will turn out great. When you're all done, post this work to Seesaw and let us know how you did. It would be awesome to see if you won or your partner won, and maybe what is something you would have done to make things better for you. All right. So, how the questions that you're going to ask, right? Number one, which strategy you're going to use to solve your division problem. So which one works most efficient for you? It may be the standard algorithm for me. Other people like using arrays. Other people like using ratio tables. How are you going to solve your problems the most efficient way? How can you arrange your cards to have the biggest quotient? Now, I might have just given a little bit away, but you want to divide a smaller number into a larger number, and that's going to give you the larger quotient, right? What should you do if you have a remainder? Oh, that's, are we going to add? Are we going to add the fractions together to be more precise, or are you going to just forget the remainders? That's up to you. It's your game. You decide. And what happens if we did play with the remainders? How would it change the game? We'll just make it a little bit more hard, a little bit more difficult when because you'd have to have the remainders written as a fraction, right? And you put the remainder over the divisor and then you reduce. Okay. Awesome. If you don't have any other questions, just play, have fun with this, enjoy yourself. But again, post your results so that we can kind of see what you've done. All right, that's the end. Today, why don't you, if you have some extra time, go take a look at our Unit 7 online resources. We also have the main number corner online resources for you guys to look at. And then if you want to play this workplace game again, fastest to 100 quotient race, you can go ahead and do that. Go ahead and print off as many copies as you want. But when everything's all said and done, make sure that you open your student book to page 272 and you finish that. Oh, I almost forgot. Yesterday's homework, right? So I'm going to put yesterday's homework up. Go ahead and pause the video, make the changes that need to be changed. If you have any questions, make sure you reach out to your teacher so that you can get things figured out as quickly as possible. Here's page 268 in your student book. Pause the video and make the necessary changes that need to be made. And then here's the home connections, pages 139 and 140. All right, so again, reach out to your teachers if you have any questions. If you don't have any questions, have a great day and enjoy math.